Hello everyone. This is lecture 71 of Principles of Electric Circuits. Let's talk about the frequency characteristics of MOSFET amplifier. Before the discussion, we first review MOSFET. We introduced MOSFET in lecture 9. We found that MOSFET can be seen as a controlled resistor through simulation. It can also be seen as a dependent source. We discussed all kinds of gate circuits in lecture 24 to 26 using this part of the controlled resistor, such as inverters. We discussed amplifier in lectures 42 to 45 using this part of dependent sources, current source. In this semester, we introduced the parasitic capacitance in MOSFET. Our main consideration is the capacitance between G and S. We've discussed the transmission delay of the gate circuit after introducing the parasitic capacitance in lecture 52. In this lecture, we will talk about the low-pass effect of the amplifier circuit with the parasitic capacitance. Let's review the basic principle of MOSFET amplifier. The characteristics of MOSFET are as follows. Firstly, the terminal G is insulated forever. That is, Ig is always equal to 0. Secondly, when UGS is less than a certain value, DNS is an open circuit. MOSFET can be expressed by the module at this time. Thirdly, it's conducted between DNS after UGS is greater than UT, which can be seen as a two-terminal element. The characteristics of the port voltage and current are like this. This part can be seen as a voltage-controlled current source, that is, you can find from the figure that the condition of meeting the VCCS is that UDS is relatively large. So, from the expression, we can also see that it is a current source controlled by UGS, so it's a nonlinear VCCS. In this section, we can model it as a voltage-controlled resistor, but for convenience, we often see it as a fixed-value resistor. If we need to design an amplifier by MOSFET, it needs to be worked in this section. The formula and the condition need to be set up. Now we assume that the input of the circuit is connected with a DC biased signal, which need to be amplified. It's a small signal circuit. We first need to analyze its DC working point. At this time, the equivalent circuit is like this. According to the analysis in lecture 45, we know that if the DC working point meets this, then we can judge that it works in the section of a VCCS. So we can calculate its working point and then draw its small signal equivalent circuit. It's like this. For the small signal, we have at this time, in the small signal circuit, nonlinear VCCS becomes a linear VCCS. So this item is thus we can get The ratio is the amplification factor of the small signal amplifier. Usually, the coefficient, which is determined by DC working point, is defined as a transconductance Gm. So the amplification of MOSFET amplifier can also be simplified as: if the excitation and response are sine signals, we can represent them by phasor with dots.